Hey guys, we're going to start working on section 5.5 today, so notice we skipped over 5.4. This will actually be the last section that we do in chapter 5. We're just choosing two of the sections and working on those, and then we're going to head on to chapter 6. So in this section, notice we're going to be working on the triangle inequality. Okay, so what we've already done, we've recognized and applied the properties of the inequalities to the relationships between the angles and sides of a triangle. Okay, so today what we're going to be doing is we're going to use the triangle inequality theorem, which I'll show you in a minute, to identify possible triangles. So remember, sometimes you cannot put any three sides together and make a triangle. Sometimes it won't be closed, or sometimes the sides will be overlapping. So you have to have a specific three side lengths in order for the triangle to actually work out. Okay, and then we'll look again at those relationships using the inequality theorem. Alright, so let's look at that theorem and see what it says. So notice you have three sides and they're color-coded. Okay, the theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, so that means if I take the red side, add it to the blue side, that sum should be greater than the green side. Likewise, take the blue and the green, add them together, that sum must be greater than the red side. And then lastly, if I take the green side, add it to the red side, I should be getting something greater than the blue side. Okay, so these three things must be true in order to make a triangle. If any one of them fails, any one of them, you do not have a triangle. Okay, and you're going to need to remember this or come back to this slide when you're working on your entry slip for tomorrow's class. Alright, so let's just practice a few down here. Let's look at number 1. 3, 4, 5. Okay, can those be sides of a triangle? Well, let's check. Is 3 plus 4 greater than 5? Yes. Is 4 plus 5 greater than 3? Of course. And is 3 plus 5 greater than 4? Yes. Okay, so this is definitely a triangle. Now notice, I really didn't need to check if 4 plus 5 was greater than 3. 4 and 5 are already greater than 3. So of course if I add them together, the sum will also be greater than 3. So really all I need to do is check the two smaller sides and make sure that those two are going to add up to be greater than the largest side. So I just needed to make sure the 3 and the 4, since those are the two shorter ones, are going to add up to be greater than the 5. And they do, so I can say yes, that's going to form a triangle. Okay, number 2, now look, these are out of order, so just be careful. The two shorter sides here are the 13 and the 11. So if you add up 13 and 11, you are getting 24. Is 24 greater than 25? No. Remember, two sides have to add up to be greater than the third one, so number 2, not going to form a triangle. Number 3, again, notice we're a little out of order. Okay, the 9.5 is actually the bigger one, so let's add. Is 1.5 greater, or excuse me, is 1.5 plus 11 greater than 9.5? Well, of course it is, because 11 is already greater than 9.5, so duh, that's going to work. Okay, let's check another one. 9.5 and 11. Of course that's going to be greater than 1.5. So remember, all I got to do is check the two shorter ones. 1.5 and 9.5, add them up. What do you get? Well, you're going to get 11. Is 11 greater than 11? No. 11 is equal to 11. So notice I need something greater, so we have to say no on number 3. Okay, and then number 4, again we have some out of order business right here. So again, we just need to add the two shorter ones. Now we do have two that are equal, so we're going to do the 9 and the 10. Yes, if I add up 9 and 10, of course I'm going to get something greater than 10. So number 4 would be yes, that is a triangle. Okay. And I think now that I'm looking back, I might have said something weird about number 3. That's not out of order. That is in order. So I just wanted to check these two shorter ones. So as long as the 1.5 and the 9.5 adds up to be bigger than the 11, we're good to go. So sorry if I messed up on that. Alright, so let's let you try one. Is it possible to form a triangle with these three side lengths, 6.5, 6.5, and 14.5? Well, remember, all we got to do is add the two shorter ones, which would be the two 6.5s. If I add 6.5 and 6.5, what do I get? 13. Is 13 greater than 14.5? It is not. Notice I had a mark through the greater than symbol. Okay. Okay, that means it is not greater. So no, this is not going to form a triangle. What about this one? I have a 6.8, a 7.2, and a 5.1. Notice they're out of order, so all you're going to do is check the two shorter ones. Which ones are the shorter ones? The 6.8 and the 5.1. So add them up. Is that greater than 7.2? Well, yes, 11.9 is greater than 7.2, so we're good to go in saying that this is a triangle. Very simple procedure. Okay, a few more. You can pause the video here and try this one on your own. Okay, notice you have an 8.5, 11.5, and a 20.5. If you add together the two shorter ones, you're going to get 20. Because 20 is not greater than 20.5, we have to say no, this does not form a triangle. One more, again, feel free to pause the video and do it yourself before you hear the answer. We have a 4.8, a 12.2, and a 15.1. Okay, so again, you're going to add those two shorter ones for 0.8 and 12.2. Because we get 17, it is greater than 15.1, so we're going to say yes, that does form a triangle. So again, these are very simple. The only thing you want to be aware of is when these happen to be out of order. Okay, so just make sure you always take the two shorter ones, regardless if they're the first two or the first and the third or the second and the third. Okay, just make sure you always get the two that are the shortest. Add them together, and as long as that sum is greater than the third side, you can say yes. Okay, now let's talk about a multiple choice question that's a little different. So instead of me giving you three sides, I'm going to ask you which of these measurements cannot be the third side, PR. Okay, so we just want to test them out. To use 7, notice, if I take the 5.2 and add it to the 7, do I get something greater than 7.2? Of course I do. Okay, so that's a yes. So that means it does form a triangle. So it's okay if 7 is the answer for that third side. What about 9? Well, notice 9 is the biggest out of all three, so that's why it's over here. So if I add the two shorter ones, do I get something bigger than 9? Yes, so this is a triangle also. If I use the 11, again, 11 would be the largest out of the three, so if I add the two shorter ones together, I'm still getting a number that's bigger than 11, so still have a triangle. Now the 13 is the one that we need to watch out for. Okay, again, the 5.2 and the 7.2, since they're the shortest ones, add them up. Notice you are getting 12.4. That is not greater than 13. So the D answer, 13, is the one that cannot be the third side. Okay, the rest of these, it's okay. But D, we cannot have if we want to form a triangle. Okay, feel free to pause the video, try this one on your own. Okay, again, we want to try all of them, but notice the one that doesn't work is the 16. Okay, so if I add together these, the 6 and the 9, since those are smaller than 16, I'm getting 15. 15 is not greater than 16, so our answer cannot be 16 for the third side. Alright, now let's talk about range for a minute. This is kind of what we were doing in the last few slides. But if I ask you to find the range of possibilities for that third side, all you're going to do is two things. You're going to take the two sides that I give you and you're going to add them together to get the upper range. Okay? And then you're going to subtract them. Make sure you take the smaller one away from the larger one to get the lower end of the range. Okay, so if I give you two numbers like 45 and 24, if I want to know the lower end of the range, I'm going to subtract 45 minus 24. If I want the upper end of the range, then I'm going to add them together, 45 plus 24. So notice the lower end of the range is 21. The upper end of the range is 69. So the third side of this triangle can fall anywhere between 21 and 69. Now notice it cannot be 21 and it cannot be 69, but it can be any number in between, like 40, or it can even be 21.5 or 68.1. Anything in between here. It just cannot be these two numbers. Okay, so really easy to find the range. Alright, let's take a look at this. This is really going to test our knowledge on the triangle inequality theorem. So real quick, the towns of Jefferson, Kingston, and Newberry are shown in the map. Prove that driving first from Jefferson to Kingston and then from Kingston to Newberry is a greater distance than driving just from Jefferson to Newberry. Now we all are thinking in our head, well duh, if we go from here to here and then there to there, okay, the easiest way is just a straight shot. Well, here's why that straight shot is always easier. Okay, remember, the two sides of a triangle must add up to be greater than the third side. So if I add this, the j to the k, and then the k to the n, then that's going to be definitely greater, or in this case longer, distance than just going from j to n. Okay, so again, this is why when you're told just a straight path is the easiest way to get there, this is why. Okay, because when you stop in between, you're making a longer distance for yourself. Okay, so feel free to pause that and read it again if you need to. All right, we are done with this section, very short. So entry slip for today. You are going to find the range of possible measures of x if the set of expressions right here represents the measures of the sides. So notice I don't just have a 3, 4, and a 5, okay, like this. I have an x in the picture, so I want to make sure I'm being careful. So notice I have 3 things to check. So here I want to check, is x plus 1 plus 5 greater than 7? Is 5 plus 7 greater than x plus 1? And is x plus 1 plus 7 greater than 5? You'll need to try those 3 things and work out each one of the equalities in order to find the value of x. Okay, so if you'll do that for me, I will check that for homework tomorrow and see you guys then. Have a great evening.